Beirut begins the day under a typical Eastern Mediterranean summer pattern. Morning temperatures rise quickly along the shoreline, humidity held close to the surface by a warm land-sea gradient. The port district starts its routine earlier than most of the city. Cargo handlers rotate through night shift handovers. Container yards activate cranes. Fuel trucks line up for scheduled transfers, and administrative offices open shutters to prepare manifests for the noon cycle. Along Charles-Éloi Road, traffic forms predictable streams, commuters moving toward the central district, delivery vans distributing goods into surrounding neighborhoods, buses pulling into the station with regular intervals. Residential blocks behind Gemmayzeh and Marmichael maintain their usual early afternoon rhythm. Air conditioning units running continuously, small shops operating under reduced midsummer footfall, and narrow streets holding the standard pattern of parked vehicles and slow local movement. Utility systems function within expected limits. Power feeds cycle through scheduled load-shedding intervals. Distribution substations in the port zone and adjacent residential sectors operate on stable output. Water pressure remains within normal ranges across coastal districts, with slight variations in elevated neighborhoods, but nothing beyond routine. Communications infrastructure carries weekday traffic, calls, data, radio exchanges between port crews and logistics offices, without fluctuations. By early afternoon, sunlight reflects sharply off metal surfaces along the docks, intensified by minimal cloud cover. The port's industrial geometry appears fixed, silos casting long linear shadows, storage hangars maintaining thermal expansion patterns typical for August, cranes moving through pre-planned arcs. For most of the city, the day holds no visible deviation. Maritime schedules proceed. Cargo inspection points maintain standard throughput. Air quality monitors in the industrial zone register chemical traces consistent with an active port, but nothing outside expected summer parameters. Residents moving through the coastal highway encounter the same spatial configuration they have known for years. Dense urban fabric to the east, port structures to the north, commercial corridors extending west. The grid is stable. Systems operate within design parameters. Nothing in the physical behavior of the city suggests that its northern edge already contains conditions capable of altering its map before the day ends. By early afternoon, small deviations emerge inside the port's operational systems, though none present clear surface-level signals. In the northern storage sector, temperature readings inside one of the hangars show slight elevation compared with adjacent units. The variation is modest, only a few degrees above the day's baseline, and appears consistent with solar heating on metal structures. Monitoring is minimal. The facility is not equipped with active suppression systems beyond standard extinguishers and basic alarms. To most staff, the numbers remain part of a familiar summer pattern. Handlers moving cargo through the yard notice a faint shift in the acoustic profile near Warehouse 12. A dull resonance behind its metal walls, less a sound than a change in how footsteps echo along the concrete. Such effects often occur when containers are rearranged, and workers continue their scheduled tasks. Inside administrative offices, a port dispatcher reviews routine documentation when a brief voltage fluctuation passes through the lighting. The dip lasts less than a second. Backup circuits stabilize the interior load. Power in coastal districts experiences similar momentary irregularity, too minor to trigger public concern, recorded only as a small anomaly in the utility's midday log. Along the docks, a pair of crane operators exchange remarks about a faint column of grayish haze rising behind the grain silos. At distance, it resembles dust from routine movement or exhaust from small machinery. The plume spreads horizontally rather than vertically, dissolving into the summer air before forming any defined structure. Wind direction from the northwest disperses it quickly, blending it with typical port emissions. Residents in low-rise buildings near Armenia Street detect a light chemical odor during the early afternoon heat, noticeable but not unusual for neighborhoods bordering industrial zones. Airflow patterns often carry mixed scents from fuel depots, refrigeration units, and maritime operations. Windows remain open. Activity continues without adjustment. In the port's northern interior, where older warehouses cluster near the breakwater, mechanical vibrations on one handling platform register slightly above normal. Maintenance staff attribute it to aging cranes operating at midday capacity. They schedule a routine check for a later shift. Farther inland, a hospital administrator in the east of the city notes a minor spike in incoming calls from the port regarding respiratory irritation among workers, but the cause is assumed to be heat and dust exposure typical of August afternoons. No alerts are issued. Traffic along Charles Hello Road slows briefly as drivers observe a thin smoke ribbon emerging from behind a row of storage buildings. The plume lacks intensity, shows no active flame, and disperses before reaching higher altitudes. Without coordinated reporting, it remains an isolated observation. Sensor logs at the fire brigade control room register no alarms. For several minutes, the haze thickens slightly, forming stratified layers close to the warehouse roofs before flattening out under the afternoon inversion. Temperature inside the structure continues climbing, but the shift blends with ambient heat signatures and does not breach thresholds that would trigger automatic responses. From the sea, crew aboard a small cargo vessel preparing to berth notice a shifting glow inside the warehouse, an intermittent pulse through gaps in the metal siding, too faint to classify. Sunlight reflections off nearby cranes make the observation ambiguous. Radio communications remain routine, carrying no reports indicating developing hazard. Inside the port's spatial grid, the circulation of trucks and forklifts continues, engines generating familiar noise patterns. Yet subtle shifts accumulate. Slight discoloration near the upper panels of Warehouse 12, faint rippling distortion over its roof, an unusual density in the air directly above the structure. Operators working nearby sense elevated heat radiating outward, detectable as a difference between walking past sun-exposed metal and something more concentrated. They interpret it as normal thermal expansion amplified by the day's high temperatures. The anomalies remain scattered, each small enough to dismiss, none coordinated into a system-level signal. By mid-afternoon, a localized internal reaction within the warehouse accelerates, producing brief bursts of particulate matter escaping through structural gaps. These releases are momentary, nearly invisible to the untrained eye, and disperse before forming recognizable smoke columns. Monitoring equipment in the port logs pressure fluctuations too slight to warrant immediate investigation. Life in adjacent districts, Gemmayzeh, Karantina, Mar Mikhail, carries on unchanged, cafes operating, residents moving through narrow streets, buses loading at the terminal. The port continues functioning within its visible routine. For those nearby, the day remains ordinary. For the systems embedded within the northern storage block, small deviations compound unnoticed. The conditions developing behind the metal walls remain unseen by the city that surrounds them. Through the late afternoon, Beirut maintains its usual weekday rhythm. Traffic along the coastal highway thickens as shifts rotate, but movement remains orderly. Commercial districts east of the port experience their standard midday lull. Shops half-shuttered against the heat, residents resting indoors, delivery routes completing their scheduled loops. Inside the port perimeter, operators continue working along predictable lines. Forklifts transport pallets across sun-heated concrete. Trucks enter and exit the gates at controlled intervals. Administrative staff process clearances, review manifests, and coordinate incoming shipments. Nothing in the flow suggests an ongoing internal escalation. The haze observed earlier near Warehouse 12 remains thin, dissipating before forming any recognizable signal. Workers attribute it to machinery or dust disturbed by container handling. No formal report is filed. A maintenance crew passes the structure briefly, noting elevated exterior temperature on the metal siding, but the observation matches expectations for August heat. They continue toward a scheduled task elsewhere in the yard. Power fluctuations recorded earlier do not repeat with meaningful frequency. Utility supervisors categorize them as minor anomalies typical of afternoons with high load demand and cyclical generator transitions. No additional staff are deployed. In surrounding neighborhoods, residents near the port hear occasional sharp sounds, metallic impacts echoing through the industrial zone. But such noises occur regularly during crane operations or container shifts. Restaurants in Mar Mikhail prepare for evening service. Side streets fill with slow pedestrian movement. Air conditioning units produce their continuous background hum. The city's ambient noise masks any irregularities originating from the northern storage block. Inside the port's control building, a fire safety console shows a brief sensor spike, then returns to normal. The reading appears on a screen monitored by a single operator, who interprets it as a glitch tied to heat distortion or faulty wiring, common in older warehouse units. No alarm sounds, no inspection is initiated. The grain silos cast longer shadows as the sun lowers. Cargo crews reorganize equipment for the evening cycle, moving closer to the docks and away from interior storage. This natural redistribution reduces foot traffic near Warehouse 12, delaying any chance of incidental detection. Communications networks continue carrying routine traffic. Radio exchanges between crane operators, vessel agents confirming berthing times, logistics offices coordinating outbound cargo. No message suggests active hazard. Along the shoreline, maritime visibility remains clear. Crews aboard moored vessels observe the port's geometry unchanged, cranes stationary between lifts, trucks navigating familiar routes. The slight distortion over the warehouse roof blends with ambient heat shimmer. In the fire brigade headquarters, staff review routine call logs. No alerts originate from the port sector. Evening crews prepare for standard rotations. Traffic police near the Charles Helou station focus on managing congestion rather than monitoring distant industrial signatures. In hospitals, patient flow reflects typical weekday patterns. No unusual influx from the port arrives to suggest emerging chemical exposure or fire. Medical teams maintain normal staffing levels. As afternoon transitions toward evening, the internal reaction inside the warehouse intensifies incrementally. Heat accumulates in a confined space with limited ventilation. Pressure rises in intervals too small to register on external systems. Thin particulates escape with higher frequency, but disperse before breaching visual thresholds. A few workers notice a faint metallic odor drifting across the yard, sharp but brief. They associate it with routine port materials, fertilizers, chemicals, fuel residues, common in storage zones. The odor does not persist. By early evening, the city continues operating with full confidence in its systems. Power cycling remains predictable. Water pressure across coastal districts holds steady. Communications remain uninterrupted. No coordinated entity detects the convergence of minor anomalies inside the warehouse. Each small sign stays isolated, a detail without context. The port transitions into the slower pace of late afternoon. Crews prepare for the evening shift. Administrative offices begin closing files. Dockside cranes idle between tasks. The city at large moves into early evening routines, unaware that conditions within an unremarkable warehouse have entered a phase that routine assumptions no longer describe. As early evening settles over the port, the shift from manageable irregularities to irreversible escalation begins quietly, without a singular trigger that the city can interpret in real time. Inside Warehouse 12, the internal reaction that had advanced unnoticed through the afternoon reaches a threshold where accumulated heat, confined volume, and reactive material interact in ways no longer compatible with containment. Pressure rises beyond structural tolerance. The first visible sign emerges as a sudden expansion of smoke from the warehouse's upper vents, denser, more cohesive, forming a continuous column rather than the diffuse haze seen earlier. The plume lifts sharply before wind shear disperses it toward the east. Dock workers in adjacent sectors stop briefly watching its form. Some interpret it as a routine fire happening deeper within the industrial zone. A few notify supervisors by radio, but the messages carry no urgency. Procedure dictates sending a small inspection team, not initiating full-scale response. The thermal load inside the warehouse intensifies rapidly. Metal panels along the roof begin to warp outward, subtle at first, then with visible distortion lines along their seams. A series of dull impacts follows, internal structures shifting under stress. These sounds travel unevenly across the port, echoing off the silos and hangars in ways that obscure their origin. Some crane operators mention the noise on shared radio channels, but traffic coordination continues uninterrupted. At the fire brigade headquarters, a second sensor spike from the port sector registers, this time lasting longer. The console flags it as a potential fire signature, but without confirmation from visual systems or on-site personnel. The dispatcher initiates a low-level alert. A single unit is assigned to check conditions. Engines begin moving toward the port, navigating through early evening congestion. Their departure marks the first coordinated reaction, though still aligned with routine protocol. Along Charles Helou Road, drivers notice the smoke column more clearly as it thickens. Some reduce speed, others continue without adjusting course. Pedestrians in Gemmayzeh point toward the port, trying to determine whether the plume originates from the silos, fuel depots, or warehouses. Information remains inconsistent, impressions scattered. In the port's administrative building, staff step outside to observe. The smoke now rises in a tight vertical formation, darkening at the base. A low-frequency vibration moves through the ground, faint, more sensed than heard. It passes quickly, not strong enough to prompt evacuation. The inspection unit from the fire brigade reaches the port gate. Security personnel direct them toward the storage block after noting increased smoke, but reporting no visible flame. Access roads remain clear. Crews proceed toward Warehouse 12 at standard speed, unaware that internal conditions are minutes away from exceeding structural stability. The warehouse exterior now emits intermittent flashes through narrow gaps, brief pulses of orange-white light, inconsistent and lacking open flame characteristics. They reflect off metal surfaces, creating distorted patterns visible from the dockside. The flashes register to observers as unusual but not identifiable. Some port workers begin moving away from the northern block, not as evacuation but as precaution. Others remain at posts, continuing their shifts. Communication between units increases, but no coordinated warning flows outward to the city. Traffic around the port maintains its gradual evening buildup. The coastal highway continues moving, though with slower intervals as drivers glance toward the industrial zone. Public buses operate on schedule. Residential districts adjacent to the port hear occasional metallic concussions, short, abrupt, originating from internal warehouse failure. The sounds resemble heavy machinery impacts common in the area. They draw attention but not action. Inside the warehouse, internal containment collapses. A sudden pressure surge forces open sections of the roof, releasing a burst of particulates and heat into the air. The plume expands horizontally before rising. This event, though significant structurally, still appears to outside observers as a localized fire. The fire brigade unit approaching the site transmits the first formal report. Visible smoke, possible interior combustion, structural deformation. They request additional support, raising the response level 1 tier. Engines, already en route, accelerate. The escalation marks the moment at which a controlled intervention might still have been attempted, but internal conditions inside the structure have progressed too far. The port's geometry begins shifting as personnel redirect movement. Security vehicles block access to one lane. Workers gradually retreat to perimeter zones. The atmosphere across the port transitions from routine to early-stage emergency mode, though not yet recognized at city scale. In surrounding neighborhoods, rooftop observers gathered to film the smoke column rising above the silos. The light beneath it pulses irregularly, giving the impression of an unstable fire. No sirens are heard beyond the port perimeter. No citywide alert is issued. Systems still operate on standard assumptions. The warehouse continues heating under confinement. A sudden internal collapse produces a shockwave that shakes nearby containers, causing stacked units to shift several centimeters. The sound reaches as far as the coastal highway, sharp, hollow, resonant. Drivers slow. Some pull to the roadside. The fire brigade unit reports structural instability. Additional crews increase speed. Emergency services activate sector-level protocols but do not expand coverage beyond the port. At this point, the event exits the realm of manageable incident. The internal reaction accelerates, no longer limited by containment or equilibrium. The port's northern block becomes a closed system with rising pressure, rising heat, and a spatial configuration no longer capable of dissipating either. The point of no return has passed, though no one within the city yet recognizes how little time remains before the environment shifts from localized emergency to physical transformation of Beirut's coastal edge. The transition from escalating internal reaction to full physical release occurs in seconds, too fast for coordinated response, too slow to prevent the chain of effects that follows. At approximately early evening, the confined pressure inside Warehouse 12 reaches structural failure. The initial breach forms near the southeastern corner, where metal panels warp outward, releasing a sharp horizontal jet of incandescent particulate and compressed gases. The discharge cuts through the air in a straight line, visible from the port perimeter as a flash without defined structure. The pressure drop triggers immediate secondary failures. Roof panels lift in sequence, not uniformly but in rapid staggered motion, each detaching under differential loads. The openings allow a surge of energy to escape upward, producing a vertical column of reddish smoke and debris that rises faster than surrounding air can absorb. The fire brigade units approaching the site register the event only as a sudden wall of dust and glare expanding across their field of view. The shockwave from the first major release travels outward at high speed. Ports structures nearest the warehouse, containers, cranes, vehicles, experience the force as instantaneous displacement. Shipping containers slide or overturn. Windows in adjacent buildings implode inward. Glass carried across interior floors before occupants can react. The grain silos, positioned between the warehouse and the waterfront, channel part of the wave upward, creating a vertical plume of dust rising along their western face. A second, larger detonation follows. This release exceeds the capacity of local air volume to distribute force. A spherical pressure wave expands outward from the warehouse at high intensity, compressing air into a visible distortion ring. Within the port, the blast sweeps across open yards, overturning vehicles, lifting debris, and bending steel elements. Cranes nearest the epicenter twist on their bases. Some collapse partially, their booms thrust sideways or downward. Storage hangars lose roof systems in a single motion. Doors tear from their frames. Within surrounding districts, the blast interacts with dense urban fabric. In Quarantina, buildings closest to the port face immediate structural compromise. Facades facing the explosion lose windows, shutters, and cladding. Balconies shear from attachment points. Interior walls fracture under pressure equalization. Vehicles parked along streets rotate or are pushed several meters from original positions. In Gemmayzeh and Mar Mikhael, the wave moves through narrow streets, amplifying between masonry structures. Window frames snap. Doors blow off hinges. At sidewalk level, dust, insulation, and shattered glass form a moving front that rolls through intersections before settling in layers across pavement and interior spaces. The shockwave reaches the coastal highway, lifting some vehicles onto medians and causing multi-directional impacts as drivers lose control. Buses lurch sideways. Motorcycles fall across lanes. Roadside infrastructure. Billboards, barriers, metal panels, detaches and scatters. The pressure wave continues inland, decreasing but still strong enough to damage structures across several kilometers. Interior ceilings collapse in residences. Suspended fixtures fall in offices. Storefronts lose glass entirely. Merchandise pushed outward into streets. Along the port edge, the silos absorb a fraction of the energy but sustain heavy damage. Sections of their western face collapse, releasing grain that cascades downward in dense volumes, combining with dust into airborne plumes. The dust cloud rises quickly above the port, forming a column hundreds of meters tall. The cloud expands outward, darkening as it mixes with particulate from broken concrete, metal, and grain. Sunlight filters through it with reddish tint, reducing visibility across adjacent districts. Sound from the blast arrives unevenly across the city. Closer sectors experience a sharp, concussive impact that triggers car alarms and shatters interior objects. Farther neighborhoods hear a deep, rolling detonation that reverberates across building surfaces. For several seconds, the city registers the sound as undefined industrial failure before the full scale becomes apparent. Within the port itself, the ground vibrates as shockwaves travel through concrete surfaces. Cranes topple completely. Containers scatter in irregular patterns. Vehicles lift, rotate, and land at varied angles, some stacked upon each other. Fire begins at multiple points. Ignited fuel, damaged lines, and fractured equipment. Water pipelines break beneath port pavements, producing vertical geysers that collapse quickly due to pressure loss. Natural gas leaks from ruptured service lines create localized ignition zones. Communication towers inside the port's perimeter collapse or lose alignment. Transmission equipment detaches from masts, severing lines that connect the port to citywide communication networks. Control rooms across Beirut register simultaneous loss of multiple systems, sudden decrease in cell coverage, abrupt drop in electricity load, failure of port-based transmitters, and sharp changes in water and gas pressure. The dust cloud moves rapidly inland, carried by the blast and coastal wind patterns. Visibility drops to near zero in some streets. Airborne debris, paper, metal fragments, insulation, pulverized masonry, circulates before settling gradually across districts. The waterfront transforms almost instantly. Sections of the quay collapse into the sea. Boats moored nearby capsize or are thrown against the breakwater. Water near the shoreline becomes opaque with suspended debris, oil slicks forming on the surface. The force of the explosion creates a temporary wave that spreads outward across the harbor basin. In the immediate interior zone east of the port, structural damage appears uniform. Buildings lose entire outer walls, exposing floors and rooms. Masonry fragments cover stairwells. Electrical wiring hangs from ceilings. Elevators stall between floors. Traffic halts across several sectors. Vehicles left running generate erratic engine noise through dust-thickened air. Pedestrians stand disoriented or move slowly through debris without clear direction. Sound following the initial blast consists of alarms, cracking masonry, falling glass, and distant sirens attempting to activate through compromised networks. For several minutes, the port zone and adjacent districts exist in a single altered environment. Visibility reduced, geometry changed, infrastructure disabled. Systems designed to absorb localized incidents have no capacity for this scale of event. The impact phase compresses into a short interval, but its effects propagate across the entire coastal edge of Beirut. When the pressure wave dissipates, the dust begins settling over a landscape whose physical configuration no longer aligns with any earlier map of the day. In the minutes following the blast, Beirut's coastal districts remain enveloped in a layered particulate cloud that obscures streets, reduces visibility to a few meters, and muffles sound. The dust settles unevenly. Heavier fragments fall quickly. Lighter particles remain suspended, drifting through open corridors and interior spaces stripped of windows. The port is no longer a functioning system but a fractured landscape of collapsed structures, overturned machinery, ruptured pipelines, and scattered containers. The grain silos stand partially intact, their damaged faces releasing intermittent cascades of displaced material. Fires burn in multiple sectors of the port, fueled by ruptured fuel lines, exposed chemicals, and debris ignitions. Pools of water from broken mains mix with grain dust and concrete powder, creating dense slurry across port surfaces. Fire suppression capacity is limited. Hydrants within the port are non-functional, and pressure in surrounding lines drops toward zero. Fire crews arriving from distant districts encounter blocked access roads, fallen power lines, and overturned vehicles. Many abandon engines at choke points and continue on foot. Navigation depends on landmarks that no longer exist. Cranes, flattened by the blast, lie across streets, and warehouse footprints have dissolved into irregular debris fields. Emergency communication degrades. Cellular service within the blast radius collapses entirely. Towers near the port are down or disconnected. Radio repeaters positioned on port structures fail, creating a communication void spanning several districts. Operators in central control rooms receive fragmented transmissions from responders moving through the debris, often too distorted to verify. Outside the immediate zone, signal congestion forces delays across the network as thousands attempt to contact family or emergency services simultaneously. Medical capacity reaches critical strain within minutes. Hospitals near the port, already operating under limited resources, experience a sudden surge far beyond design limits. Glass-covered corridors fill with incoming injured, many transported by private vehicles, motorcycles, or carried on improvised stretchers. Emergency rooms convert waiting areas, conference rooms, and hallways into triage spaces. Outdoor parking lots become treatment areas illuminated by vehicle headlights and backup generators. Power stability deteriorates across coastal districts. Substations closest to the port have sustained damage. Circuits isolate automatically, leaving large areas without electricity. Buildings that retain partial power experience intermittent outages as grid load redistributes. Traffic signals across multiple neighborhoods remain dark. Streetlights fail entirely, marking an early onset of night along the blast corridor. Across Gemmayzeh and Mar Mikhail, the scale of structural compromise becomes apparent as dust begins to thin. Entire facades have collapsed. Stairwells are obstructed by debris. Entrances are blocked by twisted shutters, fallen masonry, and broken glass several centimeters deep. Residents emerge from interior spaces in disoriented clusters, moving slowly through altered terrain. Vehicles obstruct major roads, some overturned, some crushed by falling debris, others stalled in place. Roads that once served as continuous corridors now function as irregular channels, interrupted by rubble. Emergency vehicles attempting to advance from eastern or southern districts must navigate detours onto side streets already narrowed by debris. In the port, fires spread along pathways shaped by remaining fuel and flammable material. With hydrants offline, crews rely on tanker trucks positioned outside the immediate blast area. Water must be transferred manually across broken surfaces. Smoke rises in dense columns, drifting inland and contributing to continued visibility reduction. Maritime conditions along the waterfront show deformation from the blast's energy. Sections of quay have subsided into the sea. Boats previously moored near the blast area drift without control or rest partially submerged. Oil slicks form on the surface, spreading outward under the influence of evening currents. Response teams on vessels attempting to enter the harbor find navigation hazardous due to submerged debris and unstable structures. Communication between port authorities and maritime units remains intermittent due to damaged networks. Throughout the affected districts, improvised signaling emerges. Residents shout locations of survivors. Responders use flashlights, vehicle headlights, and hand gestures in the absence of functioning electronic guidance. Large structures cast irregular shadows across streets due to the absence of grid lighting, creating pockets of darkness where movement slows or stops entirely. As night progresses, the boundary between functioning city and damaged sectors sharpens. Neighborhoods beyond the blast zone retain electricity, producing a visible contrast. Illuminated grids surrounding a central void of darkness. The affected corridor stretches inland from the port, forming a continuous zone of compromised structures, debris fields, scattered fires, and stalled traffic. Mapping systems lose alignment with physical terrain. Digital navigation tools display intact routes where roads no longer exist in usable form. Emergency coordination centers attempt to compile assessments based on partial reports. Data arrives inconsistent and incomplete. Isolated radio messages, visual confirmation from responders, and scattered civilian accounts. Without reliable aerial input during the earliest phase, situational awareness develops slowly. Hospitals report being over capacity. Fire brigades request additional tanker support. Police units redirect traffic away from the port, though most available routes remain obstructed. By late evening, the dust cloud has thinned enough for distant districts to see the port zone more clearly. Fires continue burning through damaged structures. Responders gather at improvised staging areas outside the heaviest destruction, organizing entry teams equipped with limited lighting and tools. Water distribution remains disrupted. Broken mains in coastal sectors reduce pressure across adjacent neighborhoods. Natural gas leaks persist in multiple rupture points until utility crews manually shut valves along surviving segments of the network. Communications gradually stabilize at the edges of the blast zone, where towers remain intact, but the interior remains a signal void. Late in the night, isolated generators create small islands of light at hospitals, emergency posts, and surviving government facilities. The rest of the affected zone remains dark, navigated only by handheld lights and vehicle beams. Initial casualty recordings begin, though they remain partial. Buildings near the port show near total interior exposure. Responders move floor by floor, marking areas where structural elements remain unstable. The grain silos continue shedding debris, occasionally releasing clouds of dust as weakened sections shift. By the final hours of the day, the immediate danger of secondary explosions lessens, but structural instability persists across the port and surrounding districts. Fires are contained in some areas but continue in others. Water pressure remains insufficient for broad suppression. Power restoration is not possible within the damaged grid. Navigation through affected neighborhoods remains slow and hazardous. The day ends with systems in transition, from active shock to incomplete response, from functioning coastal infrastructure to a fractured urban corridor. Midnight arrives over a city divided between illuminated districts continuing their routine and a darkened coastal zone where the built environment no longer matches its morning configuration. The catastrophe remains ongoing, its long-term consequences extending beyond the boundary of the day that contained its impact.